I'm back in my cellar again. And if you can hear that, well, I think you can probably tell I've had a bit more luck with my next DaCapo D2A converter. This one, I'm delighted to say, is working properly. It needed a little bit of fixing. The DC power supply stage over this side here was broken, but I just simply swapped out the transformer with the one from the previous D2A converter, and hey presto, everything suddenly popped into life. Now I'm delighted to say that this D2A converter has also got the much higher quality 1307 filter module, which is the one to have out of these DaCapo pink triangle D2A converters. So yeah, that's actually pretty good news. I won't give up on the other one, but for now I'm going to keep working on this one. So I thought I'd spend a little bit of time explaining what this thing actually is and how it works and why it's quite so good, because I have to say this is quite a piece of kit. And it all comes down to the circuitry that's hiding behind these two boxes and this pile of stuff here. Essentially what we have here is coming in here, we've got a digital audio signal. This is actually a board I've built so that I can connect up an optical fibre, whereas these things only usually came with a standard coaxial digital input. And there's then a bit of channel select circuitry, which is nothing particularly to worry about. But then after that, what happens next is it goes into this little box here. And this little box here is part of the secret of why this thing is quite so good. This actually is the clock recovery circuit, and there's a couple of stages of phase lock loops in here which basically take the clock signal that comes in from this board here and actually recovers it from the original digital signal and turns it into the clock that is then used by the digital filter stage and the D2A converter stages in this. From there, the clock and the digital signal go into here. So you can see you've got data SCK as two of the test points there. That's the data and basically the clock input, and it goes into this filter module, which converts it into a sort of a single bit stream. Effectively, it's a bit like a PWM kind of output. That's suitable then to be fed into this thing here, which is Pink Triangle's proprietary D2A converter. This is actually a single bit D2A converter. And if I pop the lid off here, it's actually made up of a bunch of logic chips arranged in an extremely clever fashion so that the output on here is an extremely pure bit stream. That then pops into this section of circuitry here. Now, most of what you can see here is actually power supply, but there are two operational amplifiers in here, which are Burr-Brown OPA 604 devices, and combined with this pile of stuff here, which is the analog filter stage before it goes into those, and some of the power supplies on the output here, these then basically go out into this, which is ultimately the output stage. Now, you can also see here that this stage has actually got its own separate power supply. There's a 5-volt DC and 8-volt DC power supply over here, which powers most of the digital stuff, and a completely separate analog power supply stage in here, which was the thing that was really badly blown in the previous D2A converter. Now, why this thing is so clever, the couple of things that they did in here that are extremely good. The first thing is this single-bit D2A converter is spectacular compared to any of the monolithic IC-based D2A converters of its time, and it still stands up to amongst the best D2A converters that you can buy today. The other stage that's really clever is this metal box in here where I mentioned that this does the clock recovery. And actually one of the things that's really important for digital to analog conversion is timing. And that's why this D2A converter really specialises and really gets down to the nitty-gritty of timing. Most D2A converters use a single chip, actually probably not at all dissimilar to the one that you can see on the left-hand side in here, that one there, to basically regenerate the clock from the digital signal. This one takes the regenerated clock from that and purifies it through three or even four different stages of filtering, 2 different stages of phase lock loops to give us a clock recovery signal that's accurate down to the picosecond. It is an extremely good design of D2A converter or of clock regeneration circuit, and that's why this D2A converter can really perform at its best. Now, of course, over here, the power supply stage, you can see that they've focused on an awful lot of componentry around the power supply stage for the analog, all-important analog output filter. And actually, this D2A converter, in some of its forms originally, used to come with an external battery power supply. So this entire module here basically would pop out and be replaced with a separate board. And then you'd have a separate battery power supply powering this all-important analog stage. And that's really what gave this D2A converter the edge over everything else that was out there. Now, I'm looking at this one, and this is a pretty basic model. The power supplies are quite old. The design of the clock circuitry, I'm pretty confident, can be improved because of the type of circuitry that's used in there. In fact, Pink Triangle themselves used to use another type of module this one, which you can see has actually got a clock on the module and two connectors instead of one connector. And this is to generate what's called a clock-locked signal, where you output a clock from here to the original transport and then take the digital signal back into the other connector in order to do that. And that gives you then the ability to derive a really, really high quality clock in here to make this whole clever bit of circuitry here have to do rather less work and improve the quality yet further. So I think with a bit further tweaking and some further modifications, I can take this already really good D2A converter and step it up several stages to basically bring it in on a par with some of the best things that are out there today. So I'm really looking forward to the next stage on this journey. Now I've got something that basically works.